Stars are born, they live, and they die. The sun is no different, and when it goes, the earth goes with it. But our planet won't go quietly into the night. Rather, when the sun expands into a red giant during the throes of death, it will vaporize the earth. Perhaps not the story you were hoping for, but there's no need to start buying star death insurance yet. The time scale is long, 7 billion or 8 billion years from now, at least. Humans have been around only about 40,000th that amount of time. If the age of the Earth were compressed into a 24-hour day, humans would occupy only the last second, at most. If contemplating stellar lifetimes does nothing else, it should underscore the existential insignificance of our lives. So what happens when the sun goes out? The answer has to do with how the sun shines. Stars begin their lives as big agglomerations of gas, mostly hydrogen with a dash of helium and other elements. Gas has mass, so if you put a lot of it in one place, it collapses in on itself under its own weight. That creates pressure on the interior of the protostar, which heats up the gas until it gets so hot that the electrons get stripped off the atoms and the gas becomes charged, or ionized, a state called a plasma. The hydrogen atoms, each containing a single proton, fuse with other hydrogen atoms to become helium, which has 2 protons and 2 neutrons. The fusion releases energy in the form of light and heat, which creates outward pressure, and stops the gas from collapsing any further. There's enough hydrogen to keep this process going for billions of years. But eventually, almost all of the hydrogen in the sun's core will have fused into helium. At that point, the sun won't be able to generate as much energy, and will start to collapse under its own weight. That weight can't generate enough pressure to fuse the helium as it did with the hydrogen at the beginning of the star's life. But what hydrogen is left on the core's surface will fuse, generating a little additional energy and allowing the sun to keep shining. That helium core will start to collapse in on itself. When it does, it releases energy, though not through fusion. Instead, it just heats up because of increased pressure. That release of energy results in more light and heat, making the sun even brighter. The energy also causes the sun to bloat into a red giant. Red giants are red because their surface temperatures are lower than stars like the sun. Even so, they are much bigger than their hotter counterparts. A 2008 study by astronomers Klaus-Peter Schroeder and Robert Conan Smith estimated that the sun will get so large that its outermost surface layers will reach about 108 million miles, absorbing the planets Mercury, Venus, and Earth. The whole process of turning into a red giant will take about 5 million years, a relative blip in the sun's lifetime. On the bright side, the sun's luminosity is increasing by a factor of about 10% every billion years. The habitable zone, where liquid water can exist on a planet's surface, right now is between about 0.95 and 1.37 times the radius of the Earth's orbit. That zone will continue to move outward. By the time the sun gets ready to become a red giant, Mars will have been inside the zone for quite some time. Meanwhile, Earth will be baking and turning into a steam bath of a planet, with its oceans evaporating and breaking down into hydrogen and oxygen. As the water gets broken down, the hydrogen will escape to space and the oxygen will react with surface rocks. Nitrogen and carbon dioxide will probably become the major components of the atmosphere, rather like Venus is today, though it's far from clear whether the Earth's atmosphere will ever get so thick. Some of that answer depends on how much volcanism is still going on and how fast plate tectonics winds down. Our descendants will have opted to go to Mars by then, or even farther out in the solar system. But even Mars won't last as a habitable planet. Once the sun becomes a giant, the habitable zone will move out to between 49 and 70 astronomical units. Neptune in its current orbit would probably become too hot for life. The place to live would be Pluto and the other dwarf planets, comets, and ice-rich asteroids in the Kuiper belt. One effect Schroeder and Smith note is that stars like the Sun lose mass over time, primarily via the solar wind. Planets' orbits around the Sun will slowly expand. It won't happen fast enough to save the Earth, but if Neptune edges far enough out, it could become a home for humans, with some terraforming. Since white dwarfs are heated by compression rather than fusion, initially they are quite hot. Surface temperatures can reach 50,000 degrees Fahrenheit, nearly 28,000 degrees Celsius, and they illuminate the slowly expanding gas in the nebula. So any alien astronomers billions of years in the future might see something like the Ring Nebula in Lyra where the Sun once shone. Thank you for watching. Please don't forget to subscribe to this channel, turn on the post notifications and like this video.